It's good to see you all again. Hope you did your digital system design paper good, I think. So I hope is it easy? Am I right? Easy or tough? Easy, ma'am. Yeah, because many people are afraid of that. I think I said many times the paper is going to be easy only, and in spite of that, many have skipped the exam also. So okay, no problem. So now, right, we will move on to computer architecture. Uh, Actually, this syllabus, again, this is also a hardware oriented paper, and it won't be like digital system designs. You know about digital system design. Like, what is the outcome of digital system design? Can anyone say? So, you read that paper in previous semester. Can anyone say the outcome of that subject? Can anyone, guys? The outcome of that subject is you are going to get A plus and a grade, isn't it? So what you did in that, like the entire 4 unit. So you're given some equation and some Boolean expression. You have designed some circuit, isn't it? So finally, right? Yeah, Sai Krishna, we can construct a processor using Verilog. We can design a processor using combination and sequential circuit. So obviously, right? So you gain a knowledge to design how a processor can be, because when you talk as a processor, it's a combination of combination and sequential circuit. So when you talk as a combination circuit, it is all about what? The best example of combinational circuit is arithmetic and logical unit. And when you go with the sequential circuit, uh, am I audible? Because I couldn't able to hear you. Like over voice, can you respond?
Yes, ma'am, you are audible.
Okay, yeah, okay, done. Okay, now. So, right, I mean, you have designed this combination and this sequential circuit, wherein, right, the best example for combination circuit is arithmetic and logical unit. And when you go with the sequential circuit, it is all about designing a memory. And that's what there in the microprocessor. Because when you talk as a microprocessor, it comprises of what? It means this arithmetic and logical unit and the registers. So you learn how to design those things. And also parallelly you are read another subject called computer organization. Yes. So what did you learn in that subject and what that subject is about? That's a tough subject, ma'am. Senior told, ma'am. Am I right? And again, computer architecture is also in that same list. Am I right? So I know, right? When you have been discussing with your senior, they would have said, right, computer architecture is going to be very difficult in this semester. Have you got that feedback or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. So this time, right, we will. this time, right, you are going to prove it, right? Okay, this subject is going to be more easier than the other subject. Okay, so when your junior is going to ask, you have to say, no, computer architecture is very easy compared to other remaining subject. So I need that. Okay, so now, right, we will come back to this computer organization, because there is a close relationship between the computer organization and the computer architecture. So what did you, I mean, when you just go with the computer organization, you have learned how the processor is doing it. Okay, how the processor does the work. So you are, I mean, the pipelining, all those things, I think you are learned in your things. And the first unit is all about some instruction set of ARM processors. So you have read that, right? So how it is doing. So that is by the computer organization. When it just architecture is above that. Okay, so how, what it does generally, right, what the computer does, so that is about the computer architecture. So this is the difference. Okay, so computer organizations, you learn how it is does, how the computer is does, which means, right, it is completely about the internal connections. And we learned, right, one is as a structural, another one is as a behavioral. So the same thing. So when you learn about computer organization, it is all about the structural descriptions. And when you just go with the computer architecture, it is all about the functional aspects. Okay, so this what, right, the base difference between a computer architecture and the computer organizations. The few things I need to clarify is, actually, right, because from your senior batch, like the previous batch onwards, the syllabus have been revised, wherein, right, we have been focused with ARM processor. Because earlier cases, when you go with the syllabus, we have this Intel based processor like x86, 8086 based processors. But nowadays, almost most of the systems, they are trying to use the ARM based processors. So they revamped the syllabus, and the syllabus has started covering the ARM-based processors. Actually, that's the motive of reorganizing the subjects, revising the subjects. So, I mean, it is all about ARM processors. Okay, so in CO, whatever the instructions you read, all the instructions are ARM core based instructions. Okay, ma, listen, actually today I have some workshop. Uh, um, I'm just speaking out only for 15, 24 minutes until 10 o'clock. I will be available. After that, I will give another link. You join in that link. But tomorrow, right, I will come with our usual procedure, just writing and explaining. Okay. As of introductory section, I need to want to speak to you. That's why I came. By 10 o'clock, I may wind up. I will give a link. You join in that link and you will check out. But Saturday, right, we will continue our normal way of classes. Okay. Uh, but something, few thing I need to say. That's it. Okay. So you read about the instruction set of ARM processor. When you talk as ARM, right, the base thing is, normally, right, ARM people, they are not developing their own processor, because when you take a Intel people, Intel, they develop their own the processors. Because when it just you look onto that, what is that, ARM, if you take any ARM processor, it won't be like an ARM. They will say, like, inside this you have ARM 7 core, 8 core, 9 core, 11 core. So like that they will have a okay. So this is about that's why, right, this has become very popular. And the second thing is, I mean, this word you might have heard it, right, risk based architecture and CISC based architecture. Have you heard that? What's the difference? At least have you heard this word in CO? Risk and CISC?
Yes, ma'am. Great.
Yes. Okay, what is risk and what is CISC? Please don't elaborate. Because when you talk with processor kind of things, these two words comes very closer to always processor, because normally, right, they will differentiate the processor with respect to okay, the processor is a CISC based processor, this side, right, it is a RISC based processor.
Less set of instructions.
Okay.
Reduced.
So RISC means reduced instruction set architecture, and that is the completion instruction set architecture. And here the reduced means don't think like the number of instructions. Okay, it is not with respect to the number of instructions. So the thing is, right, when you just think about the RISC architecture, um, most of the instruction will execute in single clock cycle. Okay, so almost all the instructions, not all, except load and store, the remaining instructions will execute in single clock cycle. You read all the instruction, right? Add, sub, mul, so many, not mul, so many instructions you read, right? So all those instructions will execute in single clock cycle. But when you just go with the CISC based instructions, it is not the case. Because when you have you will have a sophistications while writing a code in RISC based machine is tougher than the CISC based machine. It is easier, but when you just go with the hardware level, it is going to be a little bit complex. But tomorrow with the vacuum board, I will explain all those things. So kindly write excuse today, since I was in that meeting. I'm directly explaining. So tomorrow I will explain. Okay. I think it's going to be 10. I need to go there. So I will give a link. Please you join in that link now. Saturday we will continue. We will go with our regular class. Okay. So please don't mistake me. We join in this link. I have just posted the link in the chat, and also I will post it in the stream. You join in that. Tomorrow, I mean Saturday, we will look back. Okay. Sorry guys. Sorry. Thank you. Thank you guys.
So if I'm going to do if I'm going to do the things at a time, what is the name of that? So is it now you got the answer simultaneously? It is not possible. You agree with that point or not? You are agree with this point. Simultaneously, it is not possible. So if simultaneously it is possible means, what is a requirement? You need one more processor. You are agree?
Yes, sir.
Okay, you agree with that. But if I want to perform simultaneously, what will be the option? That is the processor. Okay, now coming to the word concurrently. Concurrency, what is mean by concurrency? Simultaneously means two at a time, two different processors. Concurrency, what is mean by concurrency? Now you will tell me the answer for concurrency. So concurrency is different, simultaneous is different. I think you agree with this one.
There may be many processes running, but only one is highlighted at a time.
We are not going to bother about which one we are going to perform. So as a thinking as a user, I want to perform the task, two different tasks simultaneously. I won't give more, for example, hierarchy for this one. So concurrency is nothing but what I think is the task concurrently it will do means there is a small gap that will have between the two tasks. That is going to be called as concurrency. So concurrency in that case, you are going to do sequentially, but that changes that what we are going to say. So concurrently means we are going to have one task to the another task is going to be the switching time is going to be very minimum. Okay. So, but the thing is, I want to achieve the speed. Simultaneously means why we have to go for simultaneously two different tasks? Why we have to go for two different tasks simultaneously? Any answer?
Time is saved. You don't need to have some gaps between your.
Yeah, you no need to wait for answer. Okay, I have one doubt here because this is the if you know the fundamentals clearly from this objective onwards, then it is easy for you to understand the remaining concepts. Okay, so if you are going to do two different tasks simultaneously, what will be the advantage? Tell me the advantage. Anyone? I have 2 tasks. I want to complete the 2 tasks.
Multitasking.
Multitasking. What is the advantage? Again, we don't want to use the new word. Simultaneously, I want to do 2 different tasks. So how, in that case, what is the advantage?
So the CPU does
We
not
can
have
make
any
the
rest time.
task.
Always new instructions will be processed.
No, basic advantage. You tell me what is the basic advantage.
We can
Time,
make the task
time.
faster.
Faster, time can be saved.
Yeah.
Time can be saved. This is the performance is going to be high. Okay, this is simple answer, no problem. Forget about the in-depth answer. But what will be the challenge? What will be the challenge?
Memory access.
What is the memory access? What is the challenge in memory access? If that system can process that way, is possible to access the processor, means there is no issue at all to access the memory. Apart from that, any other challenge you will face?
There might be
If you have
dependency between the tasks.
what is the dependency between the tasks?
Like
What is the dependency?
the output of one task may be required for the next task.
Okay, very good. But thing is, here I want to say one word. How to say this one means data dependency. Got it? What is meant by data dependency? If there is a data dependency between 2 tasks, is it possible to do the task simultaneously? Can you
Yes,
get
sir.
the question clearly? So is it possible to do the task simultaneously? Yes, answer is yes. But the problem is, if there is any data dependency, is it possible to perform data dependency? If there is data dependency means, what is basically data dependency? What is basically data dependency? Just now, somebody told the answer. What is basically data dependency?
Suppose if an operation is followed by another operation, the date present in previous operation gets changed after the operation.
Yeah. How can we say this means digital system? I think you have studied the digital system means. Can you compare this one with that example in digital system where we studied this one? Data dependency problem. I think you have studied
Forwarding bypass.
in digital system. You have studied the same concept. Whether you have studied shift register,
Flip-flop.
flip flops. Yeah. What is there in data dependency in flip flops? What is data dependency? In shift register, I can straight away I will give you the answer. Shift register. What is data dependency? The output of the previous block or stage is given as input to the next one. You got that? Whether this is the thing you have studied in your earlier class. Okay, so in that case, you have to complete that first one. You have to complete the task 1. Then only you can able to perform task 2. So that is called as data dependency. So if I want to do the task parallelly, there should not be any data dependency. Otherwise, we have to perform concurrently. That is the objective. Objective 1 is in that first line, we have to emphasize on understanding concurrency at different levels. So we have to know how concurrently we can perform. So for that, but concurrently we have to do at the same time we have to do the task parallelly, or otherwise I want to do some portion. So you have a task. So in that case, some portion can be done parallelly, some portion cannot be done not parallel. So what is the some portion? I can do that earlier preliminary works. So there should be something called a preliminary works. but execution is not possible. So that how is it possible? For that only the remainder. Any doubts in this you can ask me. You have any doubts in this you can ask me. So concurrent, for example, parallelly something cannot be happen. Because one important bottleneck is data dependency. If there is any data dependency, how can I overcome the data dependency? But I need increased speed. I need some performance. So in that case, how can I do all those things? So for that only, we are going to study something called as instruction level parallelism, thread level parallelism, data level parallelism. So if I want to do that concurrently, I want to perform a task. In that case, I can look forward for instruction level parallelism, thread level parallelism, data level parallelism, and then memory hierarchy. Memory, what is mean by memory hierarchy? So we have a different stages of memory. So you all know there will be two different, primary memory and then secondary memory. So you have to optimize that all those things. That is called as performance. Then if you do all those things, performance optimization, the quality of service get increased. Performance get increased, throughput get increased. Okay, computational complexity get reduced. These are all the advantages. So you have any doubt in this course objective, you can tell me. You have any doubts, you can ask me. You have any doubts in this, you can ask me now. So the objective is the aim, the aim of the course is describe that a range of architectural design. We have wide variety of architecture is available. Why we need wide variety of architecture? So in order to understand how that things can be done concurrently with different levels of instruction level parallelism, thread level parallelism, data level parallelism, and how we can exploit that memory. Because once the processor picture gets over, next we have to think about memory. In that case, how effectively I can use those memory, how optimally I can use that memory in order to increase the performance. So any doubts in this subjective, you can ask me now. So in order to achieve this, we have unit 1, unit 2, unit 3, and then unit 4. So that unit 1, first we are going to have, these are all the things you have to know. So how to identify technology to improve modern implementation. You all know what is meant by modern implementation. So in that earlier days, if you refer to a system, so computer system, they are built with, that architecture is built with vacuum tubes. So after that, in that integrated circuits comes to picture, linear integrated circuit, transistor level upgradation. So that is why I think you are going to study about the first generation of computer, second generation of computer, third generation of computer. People are now, we are going to think about Core i3. We have a different Core i5, i7, so many versions, so many modern implementation are available. So those things you are going to identify. So in this course, you are going to identify what will be the modern implementation, how I can perform a task. So basically, you are going to do something, means you are going to use that system in order to complete the task. That is the basic objective. If I want to perform a task, is it possible to do some latest methodology, latest processor, latest core, or anything, whatever you have in your mind? So that is going to be upgraded one. Is it possible? Yes, the answer is yes. And then the second thing is, you are going to study in that unit 1 how to select a technique. How to select a technique. You are going to have the pipeline to increase the parallelism. So today, it is not possible to understand pipeline concepts. I will tell you what is basically pipeline. So in that case, in your unit 1, you are going to study the pipeline concept, how that pipeline can increase the parallelism at the instruction level. So you all know, if I want to perform a task, I have to instruct that system. You have to do this kind of procedure. You have to follow that procedure. Anyone can tell me what is the procedure for in order to perform A plus B equal to C? What will be the instruction you will give it to the system? A plus B equal to C. Yeah, tell me what will be the procedure? A plus B equal to C. Any idea? Sir, any tell me that A plus B equal to C, any procedure, what is the procedure you have to say? Just tell me.
Add CAB.
No. What will be the first step you will do? What will be the second step? What will be the
Data into A and B.
First I have to get the data for A. That is the first step. I have to get the data from B, and then I have to perform addition, perform the function addition, and then I can store the result in a particular C. Okay. If I want to, whether this step is alone more than this procedure is alone more than sufficient, whether this procedure alone more than sufficient, as a developer, you have to say where I can get the data for A. You have to tell, and then you have to say where I can get the data for B, and then I have to perform C. After that, you have to say where I have to store the data result. So these are all the things called as procedure. So we are going to use that word procedure, but system point of view, anything can be understood based on instruction. We are going to use that word instruction. So we can't say, you can't use your microphone to say that system, you add, get the data from this particular place, add that to, and then you can store the result. You can't say. So in that case, what you have to do, you have to instruct that system. So you have to give, you have to type that instruction, and then based on the instruction only, that system can perform the task addition. So in that case, you have to know instruction level parallelism. So what is mean by instruction level parallelism? How I can perform two different instructions at a time. That is called as instruction level parallelism. So you have two instructions. What is the two instructions? I have to get the data for A, I have to get the data for B. So simultaneously, I have to perform this one in a single step, then it is going to be called it as parallelism. So in that case, how instruction level parallelism can be achieved, that you can going to study in that unit 1. So this is the overall outline of your unit 1. So unit 1, you are going to study about instruction level parallelism. In that instruction level parallelism, I'm going to study about pipeline. With the help of pipeline, I can be able to perform instruction level parallelism. That is unit 2. Unit 1. Unit 2. So you are going to study, already I told you, you are going to study variety of architecture. In that, one of the architecture is vector architecture. So you are going to study about vector architecture. One important, again that instructions comes into picture. So in that architecture also, you are going to study about one instruction called single instruction multiple data. Single instruction multiple data. Can you give answer for this one? SIMD, single instruction multiple data. What is basically single instruction multiple data? Single instruction means A plus B. So that is single instruction multiple data. First I will give you 5 plus 3. After a period of time, I will give you 6 plus 3. 7 plus 3. That is going to be multiple data. Single instruction multiple data. So that I am going to study. After that, in that same unit, I am going to study thing called loop level parallelism. What is mean by loop level parallelism? What is basically a loop? Why we have to go for loop? What is the advantage of loop? First, you tell me what is the advantage of, why we have to use that looping concepts. Anyone? What is that? Why we have to go for looping?
Sir, if you want to do the same work n number of times, we should have to go for loop.
Exactly. Very good. Very good. So if I want to perform that operation multiple times, so in that case, looping can be done. Okay. So in that case, how effectively I can perform looping? Any answer? If I want to increase the performance, how can I increase that looping concept?
Proper condition.
Yeah, proper condition. So that is going to be called as, if condition satisfy, I have to going to perform loop. If condition is not satisfy, I am not going to perform. That is different. That is you are going to instruct that system, something like that. Okay. So now you tell me, you have done some C program in your lab. What is the challenge you have faced in your looping statement based on
Infinite
speed?
loop.
Huh?
Oh, sorry.
What happened? Tell me, no problem. You have studied C programming. In that case, what is the challenge you will face while you are implementing the looping statement? Any answer? Okay. You tell me, what is the steps to be followed when looping statement occurs by the system?
So we should identify the starting point and the terminating condition.
Nah?
We should identify when the loop starts and when it should terminate.
Yeah, okay. After that,
For every condition, it should check whether it is satisfying the. For every looping, it should check.
okay, I equal to 0, I plus plus.
For normal operation, it can proceed normally. But suppose if we take while loop, while I less than 10, I plus plus. First, I is equal to 0 initial value. It will increase 1 to 1. Again, it will check less than 10. So, two operations are taking place. Checking and again doing the process.
Yeah, you have to check for whether the condition is satisfied or not. If the condition is satisfied, I have to perform the operation. Okay, you got it. Every time the system has to verify, then it has to proceed with the function. Okay, so that is called as challenge with the looping. So in that case, how effectively I can handle this particular situation, that is called as loop level parallelism. That is called as loop level parallelism. So if I'm going to have, for example, 1000 times I want to repeat that process. So check. So what we have to do? First, I have to check whether this condition is satisfied, whether this is gets, for example, whether I am going to start with 1 and then I am going to increment. First, I have to start with 0 and then I have to increment. Again, I have to check whether it is reaches that maximum limit or not. And then I have to do that function repeatedly if I'm going to do. So if I'm going to do this process for 1000 times, you have to check how much time it will took. So in that case, the processor cannot perform any other task during this period also. So in that case, how that loop level parallelism is achieved? You got it? So that is the answer. So you have any doubts now? Instruction, what I think you might have understand what is basically instruction level parallelism, what is mean by loop level parallelism. Why we have to go for instruction level parallelism? Why we have to go for loop level parallelism? Any doubts in this? Again, I will repeat. Whether my concept is clear, what is basically instruction level parallelism? What is basically loop level parallelism? Any doubts in this, or otherwise you didn't understand? Any comments on this, you can tell me. I didn't understand, sir, properly. If you want,
can you please repeat, sir?
Which one, da? Which one I want to repeat? Loop level parallelism or instruction level parallelism?
Loop level parallelism.
Okay, loop level parallelism, I told you, very simple. I equal to 0. You have declared I equal to 0, and then I is less than 5 or something like that. So you have the limit, or otherwise 5. So what you will do? You will start with 0. So what it will check whether this condition is satisfied or not. After that, if it is not 0, if it is 0 means it will get into the loop, and then it will perform any operation, and then it will come out. After that, what it will do, again it will check for either it will increment. Once that iteration gets over, increment, and then it will check for the maximum limit, whether it reaches 5 or not. If it is not reaches 5, again I have to get into that loop, and then I have to repeat the process. Again I have to store all those things. You got it? No, this is the normal operation. So in that case, if if I'm going to perform, or otherwise if I want to carry out this kind of job, is it possible to increase the performance? Is it possible to perform parallelly, something like that? So in that case, I have to do some parallelism along with the loop level. So that is the thing you are going to study in unit 2. Now you got it. Any doubts in this? Still you have any doubts? I think one fellow asked whether you have get cleared or not.
Yes, sir. Yes, sir.
Yeah. Now, again, the unit 3, you are going to think about distributed shared memory. What is meant by shared memory? Anyone? Any answer? Shared memory. Basic architecture, centralized system, distributed system. What is basically distributed system? What is basically distributed system? What is basically distributed? Anyone? No idea about distributed. So tell me, if there is no idea, tell me, I will tell you what is basically distributed system. So you want answer from me? At least say yes or no. Hello? I think 1 or 3 people are online. Anyone can answer. What is basically distributed system? Whether it is audible?
Yes, sir.
It is audible, sir.
Okay. Well, now audible means now so many people are answering, but what is basically distributed system? Any idea? Just tell me. Share your views.
Generally, distribution in the sense sharing a thing with others. So distributed system in the sense, I'm just relating it, sir, whether I don't know it is correct or wrong.
Yeah. Tell me. That's what. If you
Yeah,
have means,
so-
then only will get clear.
Distributed system in the sense, the particular system is distributed for different tasks.
Okay, I'll tell you. Here I will tell you. Distribution means, so you have one task. So what you will distribute in that, for example, you have 10 lines of code for the task. So what I will do, I will split that into multiple n value, and then I will give those things to different system. That is going to be called as distributed system. Now you got it. So you have one task. So for example, if I want to clean one room, what you will do? So somebody will, for example, somebody will take care of cleaning of the hall. Somebody will take care of cleaning of room. Somebody will take, for example, in your house, if you want to do some cleaning. So what you will do? Your, for example, your father will do some cleaning in your, for example, in your and then kitchen is taken care by your mother, and then your thing is taken care by your shelf, all the things. Then it is going to be called as distributed. You got it. What is the basic task? What is the main primary objective of the task? You have to clean your house. So then you are going to distribute. So you are going to be one system. Your father is going to be one system. Your mother is going to assume that you are going to be 3 systems. So what you are doing, you are sharing your load with 3 people. You got it. That is going to be called as distributed system. Now you got any doubts in this? That is going to be called as distributed system. You have any doubt in this distributed system? Bhavani, now you got the answer.
It means a single system is like, I have some doubts, sir.
Yeah, tell me. That's
We are
why I'm
using
here.
the same system for different tasks. Is that you meant, sir?
No. I told you, no. That's why I told you the task is going to be cleaning. So what I told you, what are the steps I have followed? You tell me.
Like for a particular, if you take a cleaning task, the task is the same, but the persons are changing.
Persons are changing. What is the persons are changing? Somebody is take care of some area, somebody is taking up some area, somebody is taking up some different area. So what is the thing? That somebody A is going to be a system, B is going to be one system, C is going to be the system. So what is a common thing between these three systems?
The same task. Cleaning is the task.
Cleaning is the task. But what is the thing? Different portion is handed over to different people. That is going to be called as distributor. You got it?
Yes, sir. Thank you.
Do you understand this?
Yes,
that is
sir,
going to
yes.
be called a distributor. Basically, now we have in depth also, we have technically so many things are there behind the thing. But thing is, this is going to be called as distributor. Any idea? Any doubt in this? Anyone? Remaining people? Hariharan, you have any doubts in this?
No, sir.
You got it. Now everyone gets clear about distributor. Okay. Now one more word they are given in this shared memory. What is basically shared memory? Any idea about shared memory? Any idea about shared memory?
So now different processes happens, right? So it needs a location for getting its data. So when it's shared memory, the different simultaneous processes can take from the same memory. This reduces what to say, like different values. Maybe A might have become 2 in this process, and other it might have become 5. So that to reduce this problem, it might have a shared memory.
So I have given one example for basic example distributed. So anyone can give any basic example for shared memory. Similar example, practical example you might have in your daily life. You have come across the daily life. Any idea about that shared memory?
Washing machine.
Yeah, very good. Washing machine. So can you elaborate that answer for washing machine?
A dryer and rinsing will be done by rinser, and drying will be.
Yeah, that is individual task now. I think you can realize that washing machine also. But shared. What is mean by shared memory? The same example.
The same washing machine is shared by many people.
Yeah, individual house. Your house. For example, you have a shared. You have a washing machine. For example, if you have 3 people in your home, you can't buy 3 washing machine for any individual. So what you will do? You will keep that washing machine on a common place. So what you will do, if you want to wash, so you will use a particular time, and then you will wash that clothes, and then you can complete that particular task. So for example, your father wants to wash, then he can use that washing machine for a period of time. Okay. So where that washing machine is placed, it is placed in a common place. It is placed in a common place. So you have allotted a particular time for in order to washing. That is going to be called as shared. Washing machine is a system. You call it as memory. That is going to be shared by different types of people. That is going to be called as shared memory. Resource sharing. We forget about that memory sharing. This is going to be called as resource sharing. I have some resource with my system. That is going to be shared by multiple number of people. Okay. What is the problem in that? What is the problem in this? If I'm going to have a system that is going to be shared by multiple people. So washing machine, they can take that same example. In your home, you are having a washing machine. So in that case, what is the problem you will face?
Tracing.
The person should wait until first job is completed. Like
yeah, very good. Place is not a problem. So you have an infrastructure to keep that system. So you have as an infrastructure to keep that system safely, securely, all the things. Only problem occurs is two people simultaneously occupy the same time. That is a challenge. Okay, this is one issue. So A also wants the same timing. B also wants the same timing. So in that case, that will be the problem. That is going to be called it. So what happened? That collision occurs. That collision occurs. This is one case. This is one a practical issue. Apart from that, we have several issues where we are accessing a shared resources. If the resource is going to be shared, at that time, what are the challenges you are going to have? How you can effectively use that one in order to increase the performance. That is going to be going to study in that shared memory. So in that finally you are going to study something about workload sharing, how we are going to share the workload, all those things. In that unit 4, performance metrics. So you have a performance metric. So you have a different types of memory is going to be available. So you have a different types of memories available. So in that case, how that performance metrics, what are the performance metrics we can use for in order to improve the performance. So that is cache is one kind of memory is going to be used for in order to increase the performance. Okay, now whenever I am talking about this cache memory, so can you tell me what are the two different types of memories available? What are the basic two types of memories going to be available? Organization. If you are going to have one system, what are the two different types of memory available? Anyone? How it is named? Memory, how the memory can be named as?
Random access memory and for storage purpose another.
Okay. Any other information?
Static memory
So
and
data memory and instruction memory.
Yeah. But how basically the memory is going to be classified? Apart from this,
Permanent and temporary.
yeah. Okay, very good. I got so many answers from you. The answer is I have one different aspect in my mind. Primary memory, and then one is called a secondary memory. Whether you have heard about this one? Primary memory and then secondary memory. You heard anything about this primary as well as secondary?
Yes, sir.
Huh?
RAM comes under primary storage and secondary storage. Hard disk comes under secondary
Very good. Okay. RAM and then ROM is primary. Okay. Apart from that, any other primary memory you have studied in your digital systems?
Register. Cache memory.
Registers. Answer is yeah. I think you people have studied digital system very clear. Okay. So register is one of the primary memory which is going to store that content. Okay. So similarly, you have cache memory. So cache memory, I think my job is very simple to explain all those things. So you have a primary memory, you have an idea about primary memory, you have a secondary memory. So if you have a secondary storage like hard disk or something like that, not only we are not going to bother about the secondary storage, primary storage. How effectively I can use those primary memories, ROM, RAM, as well as registers. I will have the cache. So in that case, what are the performance metrics I can use it for in order to increase the performance? We are going to study. That is your content you are going to study in that unit 4. So now I will summarize that what we have discussed so far in this particular hour is start with basically what is basically architecture, what is basically a computer, what is the use of any computer. So in that case, if I'm going to use one computer, I have to know something about that architecture. So in that case, what are the different types of architecture is available, all those things we have studied according to your title. After that, we have studied something about what is the objective, what is the basic objective of this particular computer architecture in terms of concurrency, parallelism, all those things. We have got some introduction and an simple example. In that case, after that, followed by we have studied that unit 1, unit 2, unit 4, unit 3, unit 4, what are the things that is covered in that unit 1, like instruction level parallelism, what is mean by basic level, loop level parallelism, and then unit 3 talk about distributed shared memory, and then unit 4 talk about the performance metric, evaluation metrics, all those things we have covered in this particular unit. Okay, so you have any specific doubts in this, you can ask me. And don't worry, this is very simple subject and then easy to understand, and then you can get good score, all those things. We will help you to get good score in this particular subject. And then soon I will share, today or tomorrow, I will share that, for example, what will be the syllabus as well as what is the textbook you have to follow, all those things. So you can go through that one, and then you can watch my videos as well as you can go through my PPT. It is more helpful for you to prepare. So then and then, you just the only important request from your side is you have to attend the class properly, even though it is attendance is not mandatory. You have to regularly join and then gets cleared, because this little bit concept wise it is little bit tough. If you understand the concept, it's very easy. So remaining things are left. You have any doubts? If you want to discuss with me, you can ask me. Anything else? You know, any doubts, you can ask me. Any doubts?